Here we have a series of 6 equations where the instructions say to solve. So for each equation, I'm going to solve and find the value for the variable that makes this equation a true statement. The first 3 equations have just a variable, k, y, or x, that already has a coefficient of just 1. There's nothing being multiplied or divided with any of these variables. But I do have things being added or subtracted. And when I'm solving a problem like that, I'm going to be using the addition property of equality. And the addition property of equality allows me to add or subtract the same value from both sides of an equation to yield an equivalent equation. So in the first problem, I want to isolate or get x by itself. And right now I have x plus 9. In order to eliminate the plus 9, I'd have to do the opposite of that, which is subtracting 9 from both sides of the equation. On the left-hand side, I have x plus 9 minus 9, which is just x. And 3 minus 9, I can take a moment and think that through. That's the same as 3 plus a negative 9, which is negative 6. On the second problem, I have y minus 8 equals 1. To get rid of a minus 8, I could add 8 to both sides of the equation. On the left-hand side, I'm left with y, and on the right-hand side, I have 1 plus 8, which is 9. In the third problem, I have negative 3 plus k equals negative 10. So I'm focusing on the side with the k. I want to isolate it, so I need to get rid of this negative 3 that's being added. So in order to do that, I could add a positive 3. And if I do it to the left-hand side, the addition property of equality says I have to do the same to the right-hand side. So negative 3 plus 3 is 0, and I'm left with k equals negative 10 plus 3, which is negative 7. If we move down to the second row, we'll see that the variable actually has something either being multiplied by it or the variable is being divided by a number. In this case, we're going to use the multiplication property of equality. And the multiplication property of equality allows us to multiply or divide both sides of an equation by the same value and get an equivalent equation. So in the first problem, I have 4p, which means 4 times p equals negative 32. I just want to have one p, just p by itself equals a number, so I need to eliminate that coefficient, the number being multiplied. To undo multiplying by 4, I can divide by 4, and if I do it to the left, I have to do the same thing to the right. Here the 4's will cancel, and I would just get a p. Negative divided by a positive is a negative, and 32 divided by 4 is 8. On the next problem, I have negative 7x equals negative 7. Negative 7x is negative 7 times x. So again, to eliminate that coefficient, that number that's being multiplied by x, I'd have to divide by it. And I'm going to divide by the entire coefficient, including its sign. If I do it to the left side, I have to do the same to the right. And on the left side, they'll cancel out. And I'll just be left with x. And the right side, negative 7 divided by negative 7 is a positive 1. The final problem has m divided by negative 3 equals 4. And remember, that's the same thing as saying negative 1/3 times m equals 4. Because negative 1/3 times m is the same as m divided by negative 3. So in this case, I want to get rid of this division by negative 3. And the opposite of that would be to multiply both sides by negative 3. On the left-hand side, I could put that over 1 to see clearly that was canceling. And I have m, and here I have 4 times a negative 3, which is negative 12. If I had had that same problem written as negative 1/3 m equals 4, which is the alternate way to write it, I could think if I want to divide both sides of the equation by this coefficient by negative 1/3, when I divide by a fraction, it's the same as multiplying by its reciprocal. So if I want to divide by negative 1/3, I'm going to multiply both sides by negative 3 over 1. So if I do that, I'm really doing the same thing as I did above, multiplying by negative 3, and I end up with m equals 4 times negative 3, or negative 12. in all problems that we're solving, we have the opportunity to check our solution, which is a great habit to get into because it allows us to have a double check of our work. So for an example of how I would check a solution, let's check this solution up here. When I get done with the problem, I write the original equation. Oops. I should write the original equation, which was -3 plus k equals -10. And then in for k, I'm going to substitute the value I got. So now I'll have -3 plus, and for k, I'm going to substitute -7. And I'm going to ask myself, is that really equal to -10? And I add those up. -3 and -7 is -10. So those two sides are equal when I put -7 in for k, which shows me that -7 is the solution to that equation. Okay. So for all the problems I do, I have that opportunity to do my check. I do encourage you to practice doing that on a regular basis so that when you do get to a test or a quiz, you're in that habit and know a way to check your answers and catch errors.